Hi, I'm Richard Booman. I'm an engineer here at Tektronix. In this video, I'm going to show you how to use MMCX connectors to create high-quality, unplanned test points on your test boards for use with the IsoVu test system. One of the most difficult measurements to make is a high-bandwidth differential voltage in the presence of common mode interference, especially when the interference is high frequency and more than 40 volts. Tektronix's IsoVu system makes this type of measurement possible through its unique combination of exceptionally high common mode rejection ratio, common mode voltage rating, and bandwidth. But to take advantage of this performance, it's important that your test connections don't degrade the performance of the test system. If you can, it's great to design test points into your board. We've designed the IsoVu system to use MMCX connectors. These industry standard connectors provide plenty of bandwidth for our application, and they provide a shielded coaxial environment all the way to the test point for high common mode rejection and overall performance. And they're readily available from online parts suppliers for a reasonable cost. In many cases, you might want to add test points to a board that has already been built. So let's take a look at how you can install MMCX connectors on your board to create high quality test points. We'll work through two examples, one on a board that offers access to through-hole solder joints and one on a board with no through-hole vias. The first board is an evaluation board for high-voltage GaN FETs that are provided in a TO220 package. We are going to connect to the gate and source so that we can measure VGS on both FETs on this board. Since this type of package has fairly long through-hole leads, we can easily access the gate and source nodes on the back side of the board. To add a connector to this type of board, we will use this type of surface mount MMCX connector that has a solid body and a pin coming out the side that connects to the coax center conductor. We're going to solder the body of the connector to the source node since it is the lower impedance of the two nodes. We want to make sure that we don't accidentally short the gate and source through any pinholes in the solder mask. So we'll position the connector in the approximate location where we want it to get a footprint and then put down a small piece of Kapton tape. We can now solder the body of the connector to the source node. Once we're satisfied that the connector placement is correct and that we have a solid contact to the source, we will solder the center pin of the connector to the gate node. Now we visually inspect the solder joints. They look good. Next, we'll electrically test them with an ohmmeter to make sure we haven't shorted anything. These connectors can have significant extraction force, so it's a good idea to reinforce the mechanical connection to avoid damaging the board. So we'll add some epoxy to reinforce the joint of the connector to the board. Now you've got a high quality test point on one of the FETs on this board. We will follow a similar procedure to add a connector to the second FET on this board. The second board that we will work on is a little bit more of a challenge. This board also uses GaN FETs, but these parts are in a tiny chip scale package. Since the package for these parts is so small, we are going to have to use a different type of MMCX connector on this board. We are going to use a version that has 4 through-hole pins for the shield and a single through-hole pin for the center conductor. These pins are long enough and spaced far enough apart that they can straddle the package. Of course, we don't want to use all 4 shield pins, and the pins are pretty long, so the first step with this type of connector is to cut off the unwanted pins and shorten the remaining ones. We will use a Dremel tool for this since it makes the job pretty quick and allows for good control of the final pin length. Once we've removed the extra pins and the remaining pins are the length we want, we can start preparing the board. But for this type of board, we will have to connect to the gate and source nodes by scraping solder mask off the metallized areas on the board and soldering directly to the board. This area is the source for the high side FET, and this area is the gate for the high side FET. Similarly, this is the source for the low side FET, and this is the gate for the low side FET. So now we need to start the tedious task of scraping off the solder mask for these areas. Once we've removed enough solder mask, we'll clean the board thoroughly and re-inspect. We will scrape and inspect multiple times until we've removed enough solder mask to create a good attachment point. That looks pretty good. We'll add some solder flux and pre-tin all 4 nodes. We will want a lot of solder here so that the solder ball on the gate node will be tall enough to contact the center pin of the MMCX connector once the shield pin is soldered. The source connection has to be soldered first, so later it will be difficult to add more solder to the gate node. The source connection is soldered first since it provides most of the strength to the joint. If everything looks good, we will go ahead and solder the gate pin to the center pin of the connector. Now we will check the connections using an ohm meter with some very fine probe tips so that we can get in under the connector and check that everything is connected properly. We will follow the same process with the second connector on this board. These connectors will be fairly close together due to the small size of the parts and the compact layout of the board, but there is just enough room to get both connectors on here and not to have them short to each other. If necessary, a piece of insulating tape can be inserted between the two connectors. Now if things look good, we will go ahead and add some epoxy to mechanically reinforce these connections. Note that we didn't add the epoxy before both connectors were in place so that we could make any necessary adjustments to the connector locations. Installing an MMCX connector on an existing board can take a fair amount of work, but it's worthwhile because you'll finally be able to see the VGS signal for the very first time.